Introduction, contents, acknowledgements, history notes. Functional and object-oriented programming paradigms. Object-oriented world. Encapsulation example. Inheritance example. Polymorfism example. A word of object-oriented programming vocabulary. The characteristics of object-oriented programming. What's an object? Abstraction. Sample class definition. Encapsulation. Instance and class variables. Instance and class methods. Sample program. Messages. Constructors. Deconstructors. Garbage collection. Single and multiple inheritance. The ISA relationship. Polymorphism. Overloading methods as a form of polymorphism. Overloading of operators. Overriding methods as a form of polymorphism. Exception handling. Exception hierarchy. Advantages of using exception handling. Distributed objects with Corba and RMI. Corba versus RMI. Introduction into the object-oriented design. A few final remarks of double OP. 1. Introduction. 1.1. Acknowledgements. History notes. 1.3. Functional and object-oriented programming paradigms. To solve a problem, we usually think about it first generally, at abstraction level. We try to calculate resources, money, meaning we decompose the problem. In case of limitation, the human may use some tricks. If we do not have enough wallpaper, we may not cover some hidden places. Furniture, pictures, etc. can help. It means we try to organize the solution from the available resources according to a plan. These three elements, solving the problem, abstraction, decomposition, and organization together, calls a paradigm, previous programs, experience, was based on functional paradigm. Imagine that we are going to reach Trieste by car, so we start to think how to do that. According to an old paradigm of programming, we should have thought of the problem in terms of functions acting on the data. On abstraction level, think of the problem in terms of a process that solves it, meaning how to drive a car, how to collect necessary things, etc. on the composition level. Think how to break this processing down into small to manageable processing units or functions instead of how to move a car from one point to another. We recognize driving in the town differs from driving in the highway. We think how to do stopping, starting the car, etc. So we create the functions on organization level. Set up functions so they call each other according to the rules. We set up sequences of function calls, passing different arguments to the functions, etc. This is the clue. Previous approaches to programming tend to separate data from the methods using to manipulate that data. At least don't strongly encourage them to be considered the concept. This is not the typical way of thinking. We have to define a set of data structures and define a set of functions acting upon these data structures. In the real situation, we think first about the way in general, and only having chosen the way, we start to think how to get through the traffic in each of the cities and villages along the way. Then we think about details, where is the best place to stop for eating, sleeping, etc. And after we may think how to arrange the schedule for this journey, to be in a particular restaurant, at a particular time. This is an example of object-oriented thinking. No. We think in terms of objects interacting. On abstraction level, we think in terms of independent agents, objects working together to call ourselves, things to take, etc. On decomposition level, we define the kinds of objects on which to split the global task. On organization level, we create the appropriate number of objects of each kind. An object-oriented world. Object-oriented programming paradigm. From the program's point of view, an object-oriented language must support three very important explicit characteristics. We use these concepts extensively to model the real-world problems when we are trying to solve with our object-oriented programs. These three concepts are encapsulation, enhanced, and polymorphism.